Okay. There's a contest because it's Saturday. So let's do it. Oh, I haven't registered. Register. Okay. Let's do this. One. Find the area of a circle with diameter d. Wait, what? How do you do pi in? I don't actually remember how to do pi. I could just hard code the first like 10 digits. This doesn't seem like it's working. Oh, okay. There's a rectangular chocolate consisting of 8 rows and W columns. Why would you tell us this? Oh, no, I mean, I guess it's kind of part of the problem. Okay. Oh, okay, sure. Yeah. So HWQ. There are H rows initially, and then, so if it's 1, then it's off H. So, do I have to print this? I have to print V times. How big are these numbers? They're up to 100. So we're chilling. Comfortable distance. You're given a string. Can find the number of pairs of integers satisfying. That they're the same character and within a given range of distances. So in this case, we're saying 2 to 4. And so it's just this B and this B, right? Oh, these two A's are 4 apart. Okay, so the A's and the B's. Yeah, so for each character, I can just pre-compute like the number in a prefix, or I can do it running as well. I don't know which one's less annoying. But yeah, I'm going to go through every character and just deal with that character. Is it just the string as input? It's NLR on the string. Okay. So I'm going to start at the beginning and then just count. So for 0, we care about L to R inclusive. There is a two-dimensional coordinate plane. A lattice point with coordinates x, y is painted black if the larger of the coordinates is even, and white if it's odd. Among the pairs of integers satisfying among the pairs of integers in a certain grid, find the number of those for which the point is painted black. So how many points in a given range are painted black? And they're painted black if their maximum is even, right? So what does this look like? If you consider a certain range, let's say this is 0 to 10, and the other axis is like 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So whichever axis is larger, the last like row or column will just be the color of that coordinate. So like this one, in this case, is odd, so it's white. And then this one's even, so it's black. This one's white, this one's black. This one's white, this one's black, till they're equal. And now here we get this kind of thing. where now this is like 9 for both of these, and then 8 for both of these. So this is the kind of shape we get. We've got these like L shapes, and we've got some part of that shape going on. And so what happens on the negative side is so this is 0, 0. Then that's black. That's black. That's black. Again, for like all of eternity in both directions. Yeah, there's nothing special about 0, so it just keeps going like this. So how do we do this? What do we need to count? The number of black points in a range, in a grid. Okay. Oh wait, it's up to 10 to the 6 as well, so I can iterate? Why have they done that? Oh, they've drawn it too? Wait, it doesn't look like this. Oh, max of absolute value. Oh, I misread that. Okay, that doesn't look like this. Does not look like this. If it's max of absolute value, then it's a bunch of squares, like we have in the drawing. Just read problems better. I need to read problems better. So it's a bunch of squares. And so we split this up into like potentially 4 queries, each one being just in the positive XY direction or non-negative, and then we just, if it's in the positive direction, we can just iterate. I mean, we have enough time to iterate anyway, so they shouldn't be giving us the values this small, but we should just iterate through all the columns and then figure out how many we have that are like increasing on this direction, and then same for rows. Okay. I'm just going to bring this diagram over to the side so I can still see it. Not that I really need it. Should I split the problem or not? I think it makes sense to split the problem. I'm going to split the problem. I shouldn't need this, but I'm just putting it in just in case, this first line. Okay, so now I've split it. Now I've split it. This should not, like this shouldn't go on forever. It should take like at most like 2 or 3 iterations. And then now we just have to do it. So now we go through all the columns and all the rows. So we iterate through what the max is, and then we count how many points we have on this like max frontier, basically. So it's like we figure out. So if max can't be less than L. So we just have to check if max is at most R, then we have this value in the XY range. So we have to check how many values are less than this in the up-down range. So rows under max is just max minus, if max is greater than R, if max is greater than U, then U minus D plus 1, if not max minus D. Okay. Oh, that's wrong. Is this simpler? This might be, no. Let's just do this one, okay? So if we get past everything, I'm just gonna output here. What I'm solving. So this, I've split this into 2 problems, and they are 4013 and 1313. What? Why is L bigger than R? L equals minus L, R equals minus R. Yeah, no, I should be swapping these as well. L equals minus swap LR. Okay, so now I've got LR is 0, 1, 2, 3, 4, 0, 4, 1, 3, and 1, 3, 1, 3. Okay. And then let me also print each of their return values. 15 and 9. Okay, so that's wrong. This should be, the second one should be 3. So what does 1, 3, 1, 3 do? Oh, I should only be doing, yeah, that's a bit dumb. If max, I should only be doing, I can't spell. I should only be doing the odd ones. Wait, the even ones. I should only be doing the even ones. I should only be doing the even ones. That seems more legit. Okay. E. You're given n, m, and an integer sequence of length n, where each element is between 1 and m. The following operation is performed a lot of times on this sequence. Let v be the integer between 1 and m inclusive, with the fewest occurrences in A. If there are multiple, take the smallest. Then append v to the end of A. Oh no. Okay. The ith query gives an integer xi. Find the value of axi. So this doesn't change any existing position. So basically it defines an infinite sequence. So this just says 1, 2, 3, 4, 5, 6, 7, 8. It starts with the 1, 1, 2, so it's going to start with the 1, 1, 2, and then, so the one that occurs the fewest number of times. Okay. So we're going to have segments of this sequence that are like obey a specific like periodic rule. This is kind of annoying, but it's doable. Okay. Yeah. So we've got this sequence, and initially, I mean, we know obviously everything from 1 to n, if the queries between 1 and n were fine. And then everything after that is going to be periodic. So if you imagine the frequencies of everything between 1 and n, so there will be lots of numbers with frequency 0, and then some numbers with frequency 1, some with frequency 2, and so on. So the first section of the remaining sequence A after this will be a section where all the numbers with frequency 0 are written out. And then that frequency is pushed up to 1. And so if, let's actually imagine that there aren't any values of frequency 1. Let's say the frequencies we have in the array, in the initial array, are 0, 3, 4, and there's something with 7 as well. So initially, everything with frequency 0 will be pushed up to frequency 3, and that's going to be the first, like, however many of those that there are, times 3 slots, and so on. So I can just figure this out. The issue is, how do I do So I can keep track of the boundaries of these sections. There will be m of these sections. I can keep track of the boundaries of these sections, and then in each section I need to know which digits I have. I think I need to do this offline. I think I need to do this offline. Yeah, doing it offline just fixes it. Okay. Don't you love doing things offline? You have to like keep track of the indices of the queries and everything. It's great. It's lovely. But when you think of it, it's like, I can do this offline. So it's kind of satisfying for like 2 seconds, and then you realize you have to code it. Okay, so I have a bunch of positions. Okie dokie. Yeah, so I do that. Now I go through the segment. I go through the queries. So I need a frequency map. Okay, how do I do this? Yeah, I'll do a map. Frequencies. This is too much manipulation. I don't know why I'm doing this, but okay. Okay, now I've got this. I don't need the rest. I just wanted to make this. Okay. So I've got these frequencies. So now what I'm gonna do. Wait, I've done this wrong. No, I haven't. Yeah, what now I'm gonna do is go through all the queries. Oh, no, I need to go through the blocks, right? So first I need to answer indices are numbered from 1, right? A1 to AN. Okay, so I now need to go through while it's less than queue and queries answered until first is at most n. It should just be called next queue. Okay, now I've answered everything up to that point, up to n. And now we go through the batches. Current index is, so we ended, last end was on n. And what else do we care about? We care about lost frequency. So after position n, everything has frequency at least 0. So after position this, every value has frequency at least lost frec. And then now we go through these pairs. So f is the next frequency that any number has, and v is the vector of values that have that frequency in the initial array. So now we work out how many positions we're going to have. I need a data structure. Wait a minute. What? Is this a thing? Because I was about to say I need a data structure where did I mess this up? Because I need to be able to insert values and also query like the kth smallest value. I can do it in log squared. Wait a minute. Luckily, the number of distinct frequencies, right, can be at most square root of n. I think n square root of n is too high here, though. Because I'm using a set as a constant. What if I used a vector? But I'd need to sort it as well. I mean, that's fine. Sorting a vector this many times, is that bad? Looks like it's bad. N square root of n on this, right? That's like 3 times 10 to the 8 or something. But what's the constant on that like? 3 times 10 to the 8. Yeah, I don't really like the sound of that, but honestly, I feel like it's not that bad. I mean, I can try it. Because the constant, it's just like sorting once, and then you're fine. I don't know how bad the constant and sorting is, though. Okay. Oh, wait. N square root of n log n, because of sorting, right? So, yeah, no, that doesn't work. So I was saying I need a data structure where I can insert values and then erase them. Wait, for some reason I thought this was working and I just messed it up. So I was going to do it offline. At each position I insert some digits, some values. And then based on the position of the X, I can figure out which block it's in and which digit in that block it is. And so now I've just got a list of queries for saying, for each block, what is the kth digit in this block? And so I can say, when I get to the nth digit, so I'm adding digits in groups. And the kth smallest digit in each one. I think log squared might be the play. It sounds kind of annoying, but it might be the play. So parallel log squared binary search is really annoying. I don't know what I'm doing this for, but I mean, I see how to do it that way. I guess first step, I'll just turn that problem into this problem. So I guess I just number the blocks, and the query answers are pairs instead of single values initially. So I go through these blocks. Now I'm saying I have a frequency and a vector. So I take this, how many values have I picked up already? It's all the ones that had frequency 0, right? Which won't be in this, so it's just just directly the answer. And then in this case, I'm going to say answer next Q is next Q. So And I'm going to do queries next queue first. That's the position. Minus last n. Minus 1. So this is the position within the block, 0 indexed. Modulo vals, so how many different values are in the block. And so this is the 0 indexed position of okay. So after this point, qons now contains, I'm just write this for understandability, even though this code is very hard to understand. Now we just need to convert these into answers. So how do I do that? I'm doing that with some kind of parallel binary search with a Fenwick tree. This is horrible. So the Fenwick tree is just a data structure where I insert values and then I query how many values are there less than this value. And then, wait, why am I doing it parallel? Who said it needs to be parallel? Like, who said it needs to be parallel? Who said it needs to be? This is hilarious. Okay. So I'm just, I didn't need to store this even. I can just have a Fenwick tree built up of these values instead of a set, and I just binary search it, and that's log squared, and that's kind of okay, right? Because this, oh, it's Pi Day, great. What? Oh, I did plus. It's okay. So I'm just going to implement Fenwick tree because I need to practice. It's been a while. Let's do this. What am I doing? Okay, that's the tree. That's the Fenwick tree. Now we've got to use it, right? So I don't need this. I just okay. So for each position, when I've got to that block, I've just got a Fenwick tree containing the values of that block, and then I just binary search the Fenwick tree. Right? Yeah. Okay. So I don't need this. I didn't need to change this. Didn't need to do this. This was fine. Don't think I need block ID either. So this is the thing I need to do. This is valid block. Now I just need the data structure, right? So for all the values, and then we're gonna call this V, because why not? And if I don't have it, I'm gonna add it to the Fenwick tree. Okay, and then now I need to do the same things here. Also update, and then so in the middle now, I just need find kth smallest value in Fenwick tree. And so this will just be kth smallest this. Make that one indexed because why not? So now I've got to do that. So now this is binary search. So vals is the size of the Fenwick tree, right? So if k is bigger than vals, return 0. Return like some kind of error. Let's just say -1. So that I can just see it printed. I go through. Wait, I should just do a set. K's of those files. So I assume that if I have at least k values less than or equal to me. Then I move this way, otherwise I move that way. And then I return R. And that should basically be it. At the end, I just print all the query answers. How many runtime errors can I get in one go? Yeah, it's not terminating. That's great. Oh, I also didn't think of something else, but it's fine. There's another bit of code I need to write, I think, after this, like infinite block at the end. But currently this just isn't working, so, well, I assume it should work if I just say 3, 3, 1, 1, 2, 3, 1, 2, 3. Okay, still isn't working. Maybe it's something to do with this. So I'm sorting the queries by start position. Then I've got a frequency map. What? Yeah, I'm doing this wrong. Because I made it one based for some reason. Not that I think that should be a runtime error, but okay. Not at this point, at least. But this should be... Oh, okay, fine. I guess that fixed the initial runtime error. Now I'm printing something... What? Why is there so much text? Oh, these are my answers. 1, 1, 2, 3, 2, 3, 1, 2. 1, 1, 2, 3, 2, 3, 0, 0. That might make sense, actually, because, so what I'm saying is 1, 1, 2, 3, 2, 3, and then, yeah, this final block I just haven't implemented yet. So let me check this one as well, because hopefully this is also correct, but with some zeros mixed in. Where does the query end? It ends on a 3. So after the 3, we've got 30, 2, 18, 21, 7, 9, 29, 19, 27, 3. So yeah, they're all correct. I'm just missing this final block. Okay. Infinite block at the end. So I've now got all the values. So while next q is less than q, with no limit now, val in block equals queries next q first minus last and minus 1 mod vals plus 1. I'm going to do assert vals equals m. Literally, this is a copy of this line, and then this is block. Right. What do I need this for? I need it here. But I'm not doing that anymore. So this, and then add 1 to next queue. So yeah, it's literally just a copy of the inside of this section. This is fine. I think this should be fine. Let's take a look. Yeah, that's correct. The long longs are the positions. So, wait, why do I not have those? I need to have them here. I don't need them anywhere here, just the query values. And then the only time I'm handling those is just directly here, right? And I'm immediately taking the modulo something that's an integer, so it's fine. Let me read F. There's a grid again. I like grids. There's a grid. The cell is called RC. Each cell is painted black or white. RK, CK is black for K is 1 to N. So we have N cells that are black. Find the number of rectangular regions in this grid with H rows, little h rows, and little w columns such that all cells contained in them are painted white. So, like, find the number of, yeah. What? Okay, so any black cell rules out, what does it rule out? It rules out a range of rows and a range of columns. It rules out an intersection of a range of rows and a range of columns. So this black cell will rule out, if we count these little sub rectangles as at their top left corner. So like this rectangle will say is in this corner. This one will say is in this corner. So this black cell, for example, blocks this corner from having a rectangle, this corner, and this corner. So basically, this one blocks a rectangle of its own. So basically, each corner blocks a rectangle, and we just need to take the intersection of a bunch of rectangles, and that's like a known problem, right? We sort them, we do some weird stuff to them. How big are these things? Ooh, okay. Yeah, this is kind of a known problem. This reduces to a known problem. Yeah, I don't think I'm getting to G, I'm gonna be honest, because I'm not the fastest at just implementing stuff. I don't even know if I'm gonna get this done. I'm just gonna use the names in the problem. Okay. Actually, let me just immediately save the block rectangles. And I want to store the blocked rectangles by start accent. Oh, wait, but I want the total area. Oh, what I can use actually is that all these blocked rectangles are of the same size. Unless they're going off the edge of the board. And so because of that, if I'm removing a blocked rectangle, like all these blocked rectangles are, okay, this is not a standard problem, I think. I'm not sure, but because if I'm removing a blocked range as I'm doing a line sweep, if I'm removing a range, because it's always, all the rectangles are either the same size if they're inside the grid, if that makes sense. Like, if they're on the edges, they might be cut off, but if they're inside, they're the same size. So if I'm removing a block or adding a block, it cannot be covering more than one gap. Like, it can only change the situation in one gap. So it'll only affect, if you consider like all the columns, it'll only affect one contiguous, all the rows. It'll only change the blockedness of one contiguous range of rows, which means if I store do this. Do I need a segment tree for this? Because I need to do range subtract or range add. Then It's only one contiguous range, but I can't find it. I don't know where it is. If it exists, I don't know where it is. Oh, wait, I can... Wait a minute. Wait, if I... Wait, why do I know where it is? If I just find the closest one before me, the closest one after me. Yeah, this is kind of not that hard to find where it is. Okay, if I find the closest one before me and the closest one after me, then I just work out what that range is. Right, and then I know what that range is. I know if it's empty and if it's not. And if it's empty, and there's the same when inserting and when erasing. So I can find out how many that changes by. Okay. Lock in, my friend. I think I store the whole thing outside the bounds, and then I just clip it every time I take the area. So, okay. N is 0 upwards. Why could it be 0? It's annoying. Edge case. Okay. So considering the rows and columns being okay, so I just need to find the blocked positions basically. And again, I need to sort them by oh, it's a multi-set as well. Okay. So I guess I'm going to index them. Like top, bottom, and then left, right on the insert, like block top, block bottom, block top. Yeah, I'll just do all of them. And then so I input R and C. Now so it's RC minus the width. So it's the row minus the height. In this case, the height is 2 plus 1. Is block top of I is that, block bottom of I is R, right? And then block left of I is column minus width plus 1, block right of I is column. I should be taking like min of this, max of this with 0. I don't know if I will though. I'll decide that in a minute based on how this implementation goes. So now I need to move through and keep a... Okay, I've got 20 minutes. I need to move through and keep track of all the blocked positions as segments and how many there are, right? So blocked rows is 0 initially. blocked area. I'll total the blocked area, and then right at the end, I'll print height times width minus blocked area. Okay, so blocked rows, that's a running total. So I'm gonna go through. Oh, I also need to like insert these into action positions. So yeah, I will max with 0. Wait, is RC 1 indexed? RC is 1 indexed, right? Okay, so it should be max with 1 actually. Okay, so these are the action points. Then I need to go through all the action points basically, and then just count from the previous position. So okay, so section start is 1 basically. And so now I'll go through all the action points. B is just the block ID. And this is the column and the action. Okay, so I'm adding some of them and I'm removing some of them. So let's do remove. So if I'm removing a segment, I'm removing actually I'm gonna do max that one there, but I'm not gonna do it on the block top. So block top could be out of range. I need to remember that. So I'm removing a segment. So I need to erase this. And here I need to insert this, although there might be multiple as well. That's really annoying. But so I remove the segment. Now, do you have a lower bound in map? You do. Okay. So there's something that starts after me. So I need to insert. So I need to wait. So I'm unblocking this segment. Else, else I'm unblocking this segment. And then, of course, if I have segments on both sides, well, actually, I still need to do this. Yeah, there's just too much. I've made this too messy. This means there's only one before you. Yeah, I should just be doing this better. I don't know why I've done so many cases here. Yeah, this is just so bad. Actually, I'm just going to rewrite this, actually. I mean, I'm running out of time, but it's fine. This part is where you just need to do basically the same thing, but from equals max from it first plus h minus 1, right? Except h minus 1 is the last blocked index, so I actually want plus h. And then kind of same thing here, actually. I want this here. So I'll do here. And then here it's the other way around. Here it's find the range first, then you change seg from to +1, and then you incorporate it. Okay. And once you've done all these, once you've added all the points, you then just need to say, before you've done this, blocked area plus equals blocked rows times C minus section start. And section start equals C. And block area plus equals. Wait, this is actually closer than I expected to be done. Shadows a previous local. I don't have time for that, I'm afraid. Oh, it crashes. Why does it crash? Got 37 seconds to find this bug. Okay. I mean, that's wrong, probably. Unless something's just crashing on my machine. Okay, let's try and find the bug though. Does it crash on everything? I've probably just got a. Okay, I've probably just got like a major bug. Let's try and find it. Damn, I'm really like not doing implementation very well. I'm changing lots of my implementation as I go, which means I haven't really planned it very well. Like this isn't very long code, but I rewrote lots of stuff. Okay, so what's wrong with this? Let's just take sample input. I don't know if we should actually. Let me just read through it first. I've got everything here. The action positions. So I take all the points. R minus H plus 1. And R, C minus W plus 1. And C. Top, bottom, left, right. Yeah, that seems to make sense. And then I'm saying this is where I'm adding it, this is where I'm subtracting it, this is just the index of the block. So that, and then I go through all the points. I add the previous area. So if my first point's at 3, then section start was at 1. So that's just 2 times 0 added to the whole blocked set. To the whole blocked area. And then I do this. I mean, this is the key part, like everything else is fine. Or at least it shouldn't be like runtime error, which is what I seem to be getting on my local machine, at least. So now I go through all the changes on this position. I pull out the action and the block index. Okay. So now this find range finds the uncovered range within a block's span, assuming the block isn't actually in the set. So it takes the top and the bottom. The top is less than the bottom. It should be in this range. It could be the entire range if there are if there's nothing else in the segment. This value can also be less than 1, but it's fine because I'll do that, fix that later. So I'm saying if there's something before it, I've found one potential problem, and it might be a bad one. Oh no. Okay, so as in bad in the sense that it's like a simple fix, so it might be a small one. So the problem is that here from might be bigger than 2, and so I might be adding a negative value here. So I should just be saying like if from is most 2, like that fix. That shouldn't be affecting runtime errors though. So I don't know what this is. What's this shadow deck? Well, let me fix these warnings. Actually, I didn't fix the warnings because I didn't have time. Yeah, sure, I can give you this. Wait, where's the main one? Well, I've got a B already. Oh, that's fine. It's the same B. Yeah, I guess it's not nice, but it's not correct. What do you mean permission denied? Hello? I'm running my program. Wow. Wait, what's the I don't get what the problem is, to be honest, because I need to read this a bit more. It's this, but I don't see why this would give a runtime error. So if there is no action, sorry, if there is if it's a removal action, then I remove it. This should definitely exist because I'm doing this over here. So I reduce it. If that becomes 0, I erase it. And I find range for B and subtract 1 on it. In this case, I add 1 and then insert the segment. Now that I've added this, it seems legit. I don't know. I keep getting this permission denied. I don't know what's up. It's because it crashed, like heavily. Good. Git history restored. Okay, so it crashed on this, right? Yeah, it crashed on this. So it does crash. So I'm even gonna remove this if that I added just so it's like exactly how it was just to figure out where it's. I mean, actually, no, that's a stupid thing to do. That's a stupid thing to do. Where did this crash? This is simpler, but it probably won't crash. Hopefully on this, but it also gives the wrong answer. Oh, yeah, kind of obvious that like you can't use the whole grid. Some of the grid is blocked. Some of the grid is blocked. Yeah, okay, that's another mistake I've made. So where is it? If I'm doing 2x2 squares, I can't do a 2x2 square that's lower than this bottom corner. So anything in this row, in this column, is just blocked. So depending on the size of the rectangle, some of the cells are just automatically blocked. In like the bottom, some number, and the furthest right, some number of columns, rows and columns. So yeah, I've got to build that in. That isn't very hard, but that's another mistake. But neither of these are like, both of these are wrong answer type mistakes, whereas I don't see why my thing is crashing. Let's make sure it's still alive here. Yep, okay. Let me take this out and see what happens. Now it doesn't crash. So find range is crashing. Find range is what's crashing. Find range is crashing. Find range on an add segment in this case. So what am I doing? I'm doing a lower bound on segment start. So this part definitely shouldn't be crashing. This is a lower bound. Because I've done this check, this shouldn't crash. I mean, okay, let me just take these out, see if it still crashes. Oh. Okay. So it's literally this line is crashing right now. Why is this line crashing? From equals max from it first plus h. So it first. That's an iterator for a map. I mean, I did just look this up, right? I'm a little rusty on syntax. It's been a while. They're literally using lower bound here, and then the same kind of dereferencing of the iterator. So the only case this won't work is if this is out of bounds, right? But I've just checked that it is not segment start. This lower bound is not begin. So there is something before the lower bound. Oh my god. Oh my god. I wrote it instead of it too. It's a typo. Just a typo. Yeah, okay. So I had a typo for one thing. Have I still commented anything out? Yeah, so I had one typo on that, and I also had one mistake because I was missing this, and I also had another mistake because I'd missed out these rows. So yeah, this was pretty rushed. Yeah, because now the answer I'm printing is 5 for this case, for example. But the answer is 2. And why am I printing 5? Because I'm saying this works, this works, this works, this works, and this works. But none of these 3 should be working because they're all off the grid. So I shouldn't be printing 5. I should be cutting off the ones that are too low and the ones that are too far to the right. And so how am I doing this? Last row is h minus h plus 1. Last col is w minus w plus 1. And then so each time, instead of in the blocked area, I only care about the last row here. So that should fix that part. Here I should do last row times last column, like the number of rows and columns. Oh, I don't need brackets there. In fact, I need to not have brackets there. And then finally, the column part needs to be fixed wherever I'm getting to that point. So if an action point goes past last column, I should just stop caring. If C is greater than last column, break, because I don't care about it anymore. And here, instead of W plus 1, I should be in the last column plus 1. So it's a lot of changes, but they're basically the same thing. Now it says 2. Now that says 0. And that says whatever that is, which is correct. This says 12. Okay, seems legit. I'm just going to fix this, like these warnings that the compiler's giving me as well. Because, yeah, and you can see also that if I remove this, like this is a necessary fix, because sometimes you will have that, especially in the more complicated cases. Like, yeah, this is necessary. Because you get wrong answer without it. What were the issues? I was shadowing B here. I guess I just don't really need to pass the B, but I think it's nice for explicitness. So mean, I'm not using pair or action here, so I can just move this stuff. I can move find range outside, I guess, and change segment outside as well. So I'll just move these outside this just to avoid the shadowing issue. Do they even... I think I should just move these outside completely, actually. I'll move them out here. That looks nicer. What? Has this just become an issue? How has this become a new issue? Oh, this was already an issue. All right. Yeah, fix the warnings. So should now be correct. Right. This is why it's so much easier to just work with long longs, honestly. For competitive programming purposes. Yeah, we got it. So that's F. I didn't get to G. Looks... I don't like the look of digits. Yeah, we're not going to do G right now. But yeah, that was this AtCoder round. That's it. We'll see you guys next time. Ciao.